So we're going to try a couple of examples and see how it goes. So there are 4 examples here of sums and differences of cubes. Maybe make this a little bit bigger. We don't need to see all of them at the same time. So I'm going to start with 64x cubed minus 2,197. Okay, so I want to know what 64 is as something to the power of 3. So what number cubed would give me 64? So you on your calculator can do the third root of 64. So I'm going to do 64 and then I do shift and my exponent button and then 3. And I get that it is 4 to the power of 3. So I'm actually going to do a little step here where I say this is 4x to the power of 3. And then 2,197. If I cube root that, I get 13. So this is 13 cubed. You don't have to write this step in, but I find it helps. So from here, we are going to cube root the first term. So that's just going to be 4x. We are going to cube root the second term, which is going to be 13. And then the sign should match what was in the question. And then my second bracket, I take this and I square it. 4 squared is 16. X squared is x squared. I like to then square the last term. So 13 or negative 13 squared is 169. I don't know that I left enough space there. And that is going to be positive. Anytime you square a number, it's always positive. And then I will multiply 4 and 13. I get 52. So I'm going to have 52x. Like I said, I don't think I left enough room. And then the sign has to be the opposite of what I see here. So if this is a minus, this one is a plus. Now, a little hint, this second bracket will never factor as long as this is a cube. If this is like x to the 6 or x to the 9 or some multiple of 3, it might factor again. But if it's just a regular power of 3, that is as far as we're going to be able to go, and it will not go any further. All right, let's try another one. So this one here, I have 1,000 sine cubed x plus 343 cos cubed x. How do I know this is a sum or difference of cubes? Well, there's 2 terms. They are being added. That makes it a sum. Sine cubed has a power of 3. Cos cubed has a power of 3. And then if I check on my calculator, 1,000 and 343 both have nice cube roots. So the cube root of 1,000 is actually 10. So this would be 10 sine x, all cubed. And then 343, I think is 7, but I'm going to check. So 343, if I cube root on my calculator, I get 7. So this is 7 cos x to the power of 3. So this is not factored. This is just me writing what each one is as a power of 3. Okay, so I'm going to have to watch sines and coses take up a lot of extra space. So I'm going to take the cube root of this first term, which is just 10 sine x. And then I'm going to take the cube root of this second one, which is just 7 cos x. Okay, in the second bracket, I square the first term. So 10 squared is 100. Sine x squared is sine squared x. And then 7 cos x squared is going to be 49 cos squared x, and it should be plus, because anytime you square something, it's always a positive. And then I'm going to multiply these two together. So 10 times 7 is 70. And then sine x times cos x is sine x cos x. Just barely got that to fit. And this is plus, so this one needs to be a minus. Maybe I'll just zoom out a little so we can see it all at once. And that is my final factored answer. So I don't really bother checking whether that second bracket will factor because I know when it's a sum or difference of cubes, it just doesn't work out. Okay, the last two are a little trickier just because they're different types of functions. So this one here is a log, and the next one is that dreaded exponential. So I have log base 5 of 8x, and then the whole thing is cubed, plus 1. So I have two terms there being added. This has a power of 3, and then 1. 1 is a perfect square, a perfect cube, a perfect power of 4, right? 1 times 1 times 1 doesn't matter how many times you multiply it by itself, it's all 1. So I could say that this is log base 5. Now 8 is a perfect cube, but 8 is the argument of the log, and we are not allowed to touch that, right? So you can't touch the argument. We leave it exactly the same. We don't do anything with it. I'm just going to say this whole thing is cubed, and then 1 is really 1 cubed. So when I go to do the cube root, this is going to be log base 5 of 8x plus 1, right? So I cube rooted the first term, cube rooted the last term, matched the sign. And then this is going to be times log base 5 of 8x squared. So log base 5 of 8x, and then the square is going to go here inside the log. My last term is going to be 1 squared, which is just 1, and it is plus. And then in the middle, 1 times log base 5 of 8 is just 1 log base 5 of 8, or log base 5 of 8. Sorry, I forgot to mention the x, 8x. And if this is plus, this one has to be minus. And that is a 5 and not a 3. It just is very poorly written on my part. Now, if you didn't want to deal with the log, you could have done some variable replacement there if it helped. All right, we have one more to do, and this one is always, you know, exponentials are always going to be a little trickier to figure out. That doesn't mean we shouldn't try, it just means it's going to take a little more brain power. So I have 5 to the power of 3x plus 6 and 4 to the power of 3x. Now 5 and 4 are not perfect cubes, but they don't need to be because they are the base. They are what is holding up the exponent. It's just like having x down here, right? That 5 and 4, they don't have to be perfect cubes. But the exponents do need to be a cube, which means it needs to be divisible by 3. So something is a cube if the exponent is divisible by 3. So I want to try to take these and write this as something to the power of 3 minus something to the power of 3. Let's start with the 4x. 4 to the power of 3x. I want to write that as something to the power of 3. Well, when you have an exponent on an exponent, we multiply. So this would just be 4 to the power of x to the power of 3. Now this one would be 5 to the power of, what would I have to multiply 3 by to get 3x? I would have to multiply by x, right? 3 times x would give me 3x. And then what would I have to multiply by to get 6? 2. 3 times 2 gives me 6. You also could just divide, so 3x divided by 3 is x. 6 divided by 3 is 2. And then here 3x divided by 3 is x. So we could do some variable replacement here if you wanted to. You could take this out, put in A, take this out, put in B, and then put your answer back in. Or we can try to do it as is. I kind of want to try to do it as is, see how it goes, but you can always use variable replacement if you're having trouble. So for this one, I would take the cube root of the first one, which is 5 to the power of x plus 2. And then I would subtract the cube root of this one, which should just be 4 to the power of x. In the second bracket, I'm going to take 5 to the power of x plus 2 and square it. So I'm going to write that out first, and then we'll actually do it. So 5 to the power of x plus 2, and then we're going to square that. My last term is going to be 4 to the power of x, and we're going to square that, and that will be positive. And then I multiply the two together, so that's going to be 5 to the power of x plus 2 times 4 to the power of x, and if this is a minus, that should be a plus. So I'm not going to factor further, but I am going to see if I can at least simplify this a little bit. I didn't really square, I just wrote what I was going to do because I wanted to think about it a little bit more. When you have a power on a power, we multiply our exponents. So this would give me 5 to the power of 2x plus 2. I am not squaring the 5. Oops, I made a mistake. I'm not squaring the 5 because it's the base, it's not a coefficient, but 2 times 2 is actually 4, so that should be a 4. And then 5 to the power of x plus 2 times 4 to the power of x, they don't have the same base. We can only multiply when they have the same base, so I'm going to leave it as, okay. There's a spare bracket here. I apologize. I don't know what happened. I got distracted by that 2, and then I threw in an extra bracket. All right, so I'm going to have 5 to the power of x plus 2, and then times 4 to the x. And then up last, 4 to the x squared, we multiply those together. That's going to give me 4 to the power of 2x. And that's my final answer. Exponentials are always a little weird. It's just the way they are.